My name is Joe McKernan. I've been with Ballmer Associates for 6 years. I'm the structural department head here. I run projects and generally in charge of staffing and other organizational things for the structural department. I have a wife and 2 children. Started out little guys, but getting bigger and bigger. I play handball. That's been a lifelong hobby, almost lifelong. I'm from New York City, born and raised. Started out 4 years at grammar school in Manhattan, 4 years in Queens, 4 years of high school in Brooklyn, and then 4 years of college in the Bronx to round it off. Anything else?
What are some of your hobbies besides handball, or what do you want to get from the class?
From the class, I'd like to be a more relaxed speaker. I'd like to know what to do with my hands and to have a little better eye contact. Generally be more relaxed.
30 seconds more on some of the projects you've been working on.
Biennial inspection is a current project that we've worked on and just finished up the 2 years of it and starting in another 2-year round. We inspected all of the bridges in Brooklyn and Queens last time around. This time we're strictly in Queens. We're going to inspect again all of the bridges on system, off system, and it's an interesting job.
Great. Where did you go to high school in Brooklyn?
Bishop Latimer. My presentation today on the Croton Point Avenue Bridge will present the need for the project, illustrate some of the site constraints, and also present some of Ballmer Associates' solutions to these problems. Metro-North selected Ballmer Associates as a design consultant. We began work in October 1992, and final plans are due in October 1993. Construction is scheduled to start in April of '94. Construction estimate is $7.5 million, and the design fee is $900,000. The project is located in northern Westchester County on the town of Croton on the Hudson. The bridge, the existing bridge, crosses over the Metro-North commuter line, the Croton-Harmon Yard, and provides access to the Croton Point Avenue Park, as well as to Metro-North parking lots and facilities. The existing bridge currently operates 1 lane at a time in one direction. As you can see from this posting sign of 3 tons, that it is not particularly practical at this point in time. This is a photo taken a little further along the bridge. Note some of the utilities on the bridge and also some of the tracks and the yard facilities the bridge crosses over. This picture here is taken at the western end of the site. Note the temporary timber bents over here and over here, which help increase the live load capacity. This slide was taken at the center of the bridge, and it shows a stairway from the bridge down to Metro-North Railroad facilities, and also shows some of the tracks at the site. This photo here was taken on the eastern portion of the bridge. Here I'd like to point out, number one, some of the numerous tracks some of the numerous tracks at the site. This existing signal tower building which must remain, and also the steel tower which carries a number of wires both over and under the existing bridge. This picture here illustrates some of the holes in the bridge, which is the reason for its 3-ton posting. And this last slide here shows some of the repairs that we've recommended, which has allowed us to raise the posting of the bridge to 20 tons. That's the slide portion. This board here shows the project site. The first part of the project was the first difficulty of the project was to come up with an alignment. Some of the project constraints were that, again, we had to go over the existing Metro-North commuter line and maintain rail traffic. We had to cross over the existing yard tracks and, again, keep the yard in operation. And we also had to maintain traffic on the existing bridge. Another site constraint was this existing tower building which had to remain. Our current alignment, the one we've proposed, will take the bridge here, south of the bridge, meet the existing west embankment, and also meet over here on the east embankment without impacting Metro North commuter parking. With the alignment set, the next part of the project is to locate the pier supports for the bridge. On the eastern portion of the bridge, there are numerous tracks to cross over. And the actual bridge pier locations were in the only locations possible to fit between tracks with the required vertical and horizontal clearances. On the western portion of the bridge, they had more choices. But still, there's an existing yard track, and there's also yard roadways would have to be dealt with. The solution here was 120-foot spans, which came out to be the most economical spans. With the support types located, the next problem was to investigate foundations. An existing soils program found that the existing bridge is located on loose to medium sand. New York State seismic requirements preclude putting a foundation on this type of soil because of problems with liquefaction as well as differential settlement. User Rutledge, a sub-consultant on the project for us, did a site-specific investigation. They found out that, number one, that for a 500-year event, this project, the site was fine. However, in the event of a 3,000-year design event, there were problems. Our solution to this problem was to densify the soil, the top 20-foot layer. This is done with vibratory probes on approximately a 5-foot grid. Other things that we investigated were the superstructure type. We looked at concrete versus steel, and we decided on steel. A concrete superstructure weighed too much and increased the foundation costs. In addition, a cast-in-place concrete solution would have required extensive formwork over the tracks, which would have been difficult. Precast concrete members would weigh an awful lot, and their long length for the center portion of the bridge would have required us to, would have had difficulties in transporting to the site. We next looked at various steel alternates. We looked at a steel multi-girder system, and we also looked at a through girder system. The through girder system is typically not preferred because it is fracture critical. However, it does provide the advantages of a shallower superstructure. We decided on a steel multi-stringer system. We investigated it, and we were able to, with the alignment, increase the required clearance to allow us to use a multi-girder system, which turned out to be a cheaper solution as well. In conclusion, we have 9 piers. We had steel multi-girder system, and we used a spread footing on densified soil. And now, if there's any questions?
They're onto that. They're onto that.
I'd like to talk a little bit more about what I started on talking about yesterday. I'd like to demonstrate the need for the Croton Point Avenue Bridge. I'd like to talk a little bit about the site constraints, and also to give you some of Vollmer Associates' solutions to the problems we encountered. The first is the need for the project. The existing bridge is in a deteriorated condition. It is currently operating one lane, alternating in each direction, and this leads to backups in the morning and in the evening for when people go into the Metro North site. Some of the site constraints are we're operating over Metro North mainline commuter rail. We're also operating over a active rail yard that's used every day for trains. And lastly, we have to maintain the existing bridge, which provides the only access into the park at this time, and also to Metro North's rail facilities. Some of the problems we've encountered. The site itself is where we're putting the bridge is the widest place on the site. It doesn't naturally want to go there, but that's on either end is the existing roads, and we have to meet them. We also have a problem with, on the site, there's an existing signal tower that has to remain. And part of our solution is to put in an alignment that will curve in and fit between the existing curved bridge and the and without hitting the tower. So we're doing this. Some of the other problems encountered are the soil conditions. The existing soil is loose to medium dense sand, and this is a taboo with New York State's new seismic codes. New York State is getting more and more aware of the earthquake requirements. We're not quite up to California yet, but we're aware of it. And our soils consultant, Musa Rutledge, conducted an extensive study of the site and have come up with some solutions which we're implementing to avoid seismic problems. Other things we've looked at is the use of concrete versus steel. We've decided that steel makes the most sense. We've looked at different types of steel structures. We've looked at a multi-girder system. We've looked at a through girder system, which is a little shallower and would avoid some of the depth problems we've had. We've solved it by playing with the profile, come up with a profile that works, gives us the required site distance, and at the same time, we've come up with a steel girder that's economical, and this is the kind of solution we're using. So to summarize it, the bridge is necessary. The existing one is in poor shape. The site is a difficult site, but we've managed to come up and solve the problems of the site. And we've come up with a bridge that will fit where it has to fit. And now I'd like to take any questions from the audience.
Are there any concerns about transporting materials to the site?
The site itself does have, it's over an active rail yard, as you know, so that we can use rail to get in there. Also, there's an alternate grade crossing a little bit in another part of the site where we can bring things at grade, bring trucks in at grade.
Tell everybody.
Bring trucks in at grade and get material to the site. Stu?
What are some of the problems with building over the railroad yard?
The railroad yard itself is used for two things. Number one, Metro-North uses it to store commuter rail trains during the day. They deadhead the trains there and they leave them there because they have no storage facilities in Grand Central. And the second thing is this is how they take their trains into their repair yards to service it. So we have to keep these open. We can't take too many even of the yard tracks out of service at one time. Yes?
I saw the slide yesterday, and the site looks very busy with all the tracks and what's going on there. Is there a lot of room for construction laydown? What are some of the implications for construction?
We have to work very closely with Metro-North's force account people. The site is used very, very extensively. There isn't too many empty places on the site. But we're going to work with them. They're going to come up with and give us a location where we can put materials, and also to store some of the soil that has to be taken out of the site, because one of the problems is that we have to take out the hazardous material and store it on site until another contractor come along and remove it.
If this is such a good idea, why didn't somebody think of it sooner? And why didn't you think of it sooner?
The bridge itself, well, it has been one of Metro-North's problem bridges one of Westchester County's problem bridges for years. But one of the problems is it has two owners. One owner is Metro-North, and the other owner is Westchester County.
Watch your hand.
Westchester County doesn't have as much money, and Metro-North likes to take care of its railroad bridges first. And this carries pedestrian or cars over the bridge, and it's not a prime concern of Metro-North. Yes.
Joe, I don't understand. Why can't you permanently relocate the tracks?
Why can't we permanently relocate them? It's a very, very crowded site. There isn't any room in the yard itself to relocate them. We can take them out temporarily, but then there would be substandard clearances between the tracks, so we have to put them back more or less where they are right now.
Last one. Okay.
Joe, I recognize that the foundations for the structure have to go between tracks. We can't relocate tracks. Have we given consideration to stick piers versus spread footing piers to eliminate the need for excavation and disposing the hazardous material excavated?
We looked at stick piers, and one of the problems we have with them is the seismic problems. The current New York State law, as I said, is catching up with California, and there are tremendous seismic forces involved, and to put them on a stick pier would have been very difficult. And one of the solutions to that would have been to have battered piles, and that wouldn't have worked because it would have taken up too much room in the yard.
Okay, good. What were some of the things, again, that you want to do?
I wanted to be a little bit more relaxed, and still not relaxed, but I'm a little bit more relaxed than I was when I started. And I wanted to get a little more confidence, and again, haven't succeeded, but I've gotten a little bit more confident.
You sound very confident. Your voice sounds really strong, and your eye contact is perfect.
Thank you.
Yeah. Yeah.
It's a struggle. Especially the
I
hands.
know it's a struggle.
Good. Stronger presence.
Definitely.
You know, the eye contact, his voice is great. And again, the efforting of the gesturing will come when it comes, if it comes, but your voice is good. Here's the only thing for me, and I thought you're, again, much improved. When you're throwing a curveball, when you get a question that you're not a little sure of, you immediately go to a defensive kind of spot, you know, yeah. And you just have to catch yourself. You have to catch yourself that it's all the questions are good, you know, and all of them are, you know the answer, you're the expert. Just don't lose it. In other words, you get a little nervous and you're not sure now what to do, and I'm seeing the nervousness. You just got to maintain the control, take a breath, and then just answer the question. You know the stuff. Good job.
Thanks very much.